Oh hey, you've heard of the Schrodinger's cat thought experiment before, right? Cat in the box, you don't know if it's dead or alive. It's a thought experiment that probes the theory of quantum entanglement. But what exactly is quantum entanglement? Is all that cat stuff just a bunch of smart kid mumbo jumbo? Well, let's see. In 1922, Otto Stern and Walter Galash discovered that electrons have this thing called spin. And sure, it could be described as the angular momentum of an electron. An electron spin also has an orientation, either up or down. So now imagine, you have two electrons. Two electrons can have an orientation of either up and down and up, or down and down. Before we're able to measure the exact orientation of the electron spin, initially, the electrons are in a state of superposition, or a mixture of all the four variations at once. Quantum mechanics says that once we measure the state of an electron spin, we cause it to collapse, or become one of the four possible states mentioned. But what does any of this have to do with quantum entanglement? Well, each electron has a certain probability of being in any of the states. This is where it gets really interesting. The Pauli exclusion principle states that some particles, electrons included, cannot occupy the same quantum state at the same time. That pretty much rules out the electrons being up and up or down and down. At this point, each electron has a 50-50 chance of being up or down. Now, if I were to measure the spin of the first electron, the probability of the second electron being either up or down changes from 50-50 to 100% one or the other, because they have to be different. If one electron is measured to be spin up, then the other changes from undefined to spin down, even if we haven't measured it yet, always. This is what we call an entangled system. The state of the first electron changes the state of the second. When this was first discovered, some physicists thought that electrons communicated faster than the speed of light. That would of course allow for the orientation of electrons to change states so rapidly, from being in a superposition to being definitively up or down. Others, like Einstein, said that electrons have this information coded in them from the start. We just didn't know until we measured them. But others say that all of this is just random.